Good morning, guys. Welcome back. This is week 3, day 1. Today, we're going to continue practicing the rules of exponents or the law of exponents with these two exercises. A simple exercise of variable expression that's being affected by exponents and a multiplication between two fractions that are being affected by exponents. Remember, we have different rules. Same base multiplication. We add the exponents if they're on the same side of the fraction. Division of same bases, we subtract the exponents wherever the exponent is greater when we have the same variable or the same term in both sides of the fraction. Exponent 0, that will always be 1. Negative exponents, that they're actually on the opposite side of the fraction. In order for us to make it positive, if it's in the numerator, we pass it to the denominator. But if it's in the denominator negative, we pass it to the numerator positive. We got power of the powers, where we actually use a distributive property and we multiply the exponent outside the parentheses by every single thing on the inside. And the negative power of a power, when our power of a power is negative, so we reverse the whole parenthesis without changing anything else, okay? And we make that power of a power positive. Okay, so we're going to work in with those rules, with those laws. In this exercise, it's a simple exercise. We've got 3x squared, y to the negative 4, z to the negative 5, everything over 2, x to the negative 1, y to the negative square, and z, and everything to the square. Okay, there are two different ways of solving this. The first one is doing power of a power first, but you probably might get with big numbers, okay, on the inside, and we don't like that. We like to work in the simplest form, so that's why we're going to simplify what's on the inside first, okay? So we're going to do that, and then we're going to do the power of the power at the last step. So remember, I'm not going to place it, but you need to remember, numbers that do not have, or variables that do not have an exponent, they actually have an exponent 1, okay? Can we simplify the 3 and the 2? Yes or no? Can we simplify the 3 and the 2? No. Because 3 and 2 are in their simplest way, simplest form, so we don't do nothing. So let's make positives those negative exponents. So this y should go to the denominator, and this z also should go to the denominator. Now, from the denominator, this x should go to the numerator, and this y should also go to the numerator. So that's what we're going to do first. So we're going to copy the 3 and the variable x squared, because that's already positive. And in the denominator, we're copying the 2 and this z that's already positive as well. And now we're going to make the shift. Okay, this y to the 4th power should go to the denominator, and this z to the 5th power also with an exponent positive. Now from the denominator, this x is to the negative 1, so it should be x to the positive 1. Remember, I do not need a coefficient 1, an exponent 1, or a denominator 1. So I leave it as x. And this y squared also goes to the numerator, positive. And everything is being affected by the square that we have on the outside. Okay, now before we do the power of a power, we continue to simplify. So we continue to copy the 3 and the 2, okay? And now we go ahead and see if the variables are on the same side or in opposite sides. If they're in the same side, we add the exponents. If they're in opposite sides, we subtract the exponents. Okay, so we got x, both on the same side. X squared and x. What did we just say that we need to do? Add. And that would be how much? X to the what power? what power?
The x power.
To what power?
The x power.
You cannot have a variable that's an exponent of yet, at least
3.
2 to 3 to the cube, because we add the 2 and invisible 1. Okay, now let's go alphabetically. Y, I got y squared and y to the 4th power. They're in opposite sides. So what do?
Subtract.
Subtract. And where are we subtracting?
In the denominator.
In the denominator. So it will give us y to what power?
The second.
To the 2nd power, because 4 minus 2, it is 2. Now the z, where do I have the z's? They're both on the same side. Exactly, they're on the same side in the denominator. So I'm going to add. And how much will that give us?
6.
6, correct. And everything to the square. Okay, now remember, what should we do? What should we do? We should do the power of a power. How do I know that we do the power of the power now? Because we have only one variable of each, or the variable disappeared. In this case, we have one variable of each. So we are going to affect this cube by the square, this invisible 1 by the square, this 6 by the square, this 2 by the square, and this invisible 1 by this square. Remember, those red lines are not necessary for you to do them. I just place them so you can remember what we are doing, okay? Okay, so we go ahead and say 3 will now be to what power?
6.
3 will be to what power? This 3, the coefficient 3 will be to what power? Invisible 1 times 2 will be to the 2nd power. Now, x to the cube is going to be now x to the 6th power, correct. And now at the bottom, we got 2 to the 2nd power, y to the what power, guys? 4th power. And the last one would be z to what power?
12.
12th power. And am I done? Is this my final answer? Is this my final answer? Or not? Is this my final answer or not?
No.
Yes or no, guys?
No.
No, it is not my final answer. Why is that not my final answer? Can anyone please tell me why that's not my final answer?
I think you have to continue simplifying.
I need to continue to simplify. What should I continue to simplify? What exactly?
3 and 2 and 2 and 2.
Exactly, the 3 to the square and the 2 to the square. I need to leave in simplest form everything, okay? So how much is 3 to the square?
9.
9. And I copy the variable that's with it just as it is with the exponent that it has. And how much is 2 to the square?
4.
4. And I copy the variables just as they are with the exponent that they have without changing anything, because the only thing that I did was to simplify the coefficients. Now that is my final answer. Questions? No questions. We're good, 100% good. Okay, then let's go with the next exercise. Okay, that's it. You don't have no questions, then that's it. Let's go with our next exercise. And our next exercise is a fraction that's being multiplied by another fraction. Okay, and it has exponents and it has powers of a powers. In this case, it got negative power of a power. Valentina and Daniel. So the first thing that we're going to do is to make those negative exponents positives. How do we make them positive? By passing them to the opposite side of the fractions. Okay, like reversing the fraction. That's all that we're gonna do. And for you to see exactly what I'm doing, I'm gonna do this parenthesis in blue and this parenthesis in green. Okay, just for you to like perfectly see what I'm exactly doing. Okay. So the first step, I'm gonna reverse it. So everything that's on the denominator will now go into the numerator, right, Mario? So 2a, and I'm not changing anything. I'm just passing it to the other side of the fraction. Exponents remain the same. Nothing else changes but its location. Okay, so over 4a to the negative square, b, c to the fourth power, d to the negative 1 power. And now everything is going to be to the positive 2 times my second parenthesis, which I'm also going to reverse. So I'm going to have 6a cubed b squared c to the negative 3. And everything is going to be over 3a b to the fourth power c to the negative square b to the fifth power. And now this negative exponent will become a positive 1, but I don't need exponent 1, so I'm not going to place it. Okay, I'm just going to leave it like that. Okay, what's my next step? My next step will be to simplify the inside of my parentheses, okay, if possible. So question, can I simplify the 2 and the 4?
Yeah.
By what number?
By 2.
By 2. And I'm going to ask at the same time, can I simplify the 6 and the 3? Can I simplify the 6 and the 3?
Yes.
By what
Yes.
number?
By 3.
By 3. Very good. Well, I'm going to do that at the same time, okay? I'm going to simplify the numbers and then copy the variables just as they are. I'm not doing anything to the variables yet, okay? I'm just going to simplify the numbers. So 2 divided by 2. 2 divided by 2. Alessandro, how much is 2 divided by 2?
1.
1. Do I need a coefficient 1? Do I need a coefficient 1? No, so I'm not going to place it. What I'm going to do is just copy the variables, okay? Because I don't need a coefficient 1. So I'm going to say a, b to the negative square, c cubed, d. Everything over 4 divided by 2. 4 divided by 2? 2. And I copy the variables just as they are without changing their exponents, at least not yet. And it's still going to be affected by the positive 2 power of a power. Now I go with the other parenthesis. And I got 6 divided by 3, 2. And I copy my variables. A cube, b squared, c to the negative cube, everything over. 3 divided by 3.
1.
Do I need that 1? No, because it's a coefficient. So I don't need it. I just go ahead and copy my variables. A, b to the 4th power, c to the negative square, and d to the 5th power. And now for the next step, I forgot here the little line of the fraction. I'm going to pass this negative exponents positives, okay, in both parentheses. So this means that this b should go to the denominator. And that's it. Then this should go to the numerator, and this should also go to the numerator. From the second parenthesis, this c should go to the denominator, and this c should go to the numerator. I'm still going to use the different colors, okay? And we're not still doing nothing with this power of a power, so we continue to place our parentheses. And we're going to say to copy the variables that are already positive, so a, c cubed, and d, those are already positives. From the denominator, I have the 2, the b, the c to the 4th power that are already positive. Now we're going to change, okay? This b squared comes to the denominator positive, so b squared. And this a goes to the numerator, so a squared. And the d, only d. Everything to the square. Now I'm going to get rid of the parentheses on the next step, not this one, okay? So I'm going to say parentheses, and I'm copying the 2, a cubed, and the b squared from the numerator. And on the denominator, I'm copying the a, the b to the 4th power, and the d to the 5th power, because they're already positives. And now I'm going to make the flip. This c to the cube comes down to the bottom to the denominator, and this c squared comes to the numerator. Now I'm going to do, for the blue one, the power of the powers. We're just going to do one little line, but you know that it will be affecting everything, okay? No, before doing the power of a power, we can continue to simplify, okay? So we're not doing the power of the power yet. We're going to simplify first the parentheses on the inside because we don't have one variable of each. We need to have only one variable of each, or a variable that disappears, okay? So let's see if a variable disappears or not, okay? So we got on the same side, the a and a squared. What should I do? Copying the 2 because there's no other number. And what should I do when I have the same variables on the same side?
Add.
You add. So invisible 1 plus 2.
3.
So a to the cube. Now let's go alphabetically. So it goes to the b. I got b in the denominator and b squared in the denominator. So again, I add. And I got invisible 1 plus 2. That will give me, again, 3. Now I go with the letter C. I got it in the numerator, and I got it in the denominator. What should I do when I have it in the opposite sides of the fraction?
Subtract.
Where? Where am I subtracting? Where am I subtracting?
In the denominator.
The denominator, because you subtract wherever the exponent is greater. Okay, so 4 minus 3. Invisible one, right? Invisible one. Then we go with the D. I got D and D. So that is in the numerator, both of them. So it will give me D to what power? D and D? D to the square. I got one variable of each. So in our next step, I can do the power of the power. Times, I'm going to do the same thing that I did over here. And I told you that I can get rid of the parentheses because there's no exponent. So I can get rid of that. So I copied the 2 and I got the A's in different sides of the parentheses. So what am I going to do? When I have variables in this opposite sides of the fraction, what am I doing? Subtract. Where am I subtracting? We got A cubed and A. Where am I subtracting?
In the numerator.
In the numerator. So it's going to give me how much? A to the second power. Very good, because 3 minus invisible 1 is 2. Now the B, they're in opposite sides again. So again, we're going to subtract. In this case, we're subtracting in the denominator because the B has a greater exponent on the denominator. So it's going to be B to what power? B to the 4th power minus B to the square. I mean, 4 minus 2. How much is that?
2.
2. Now the C's, where are the C's? Again, 1 in the numerator, 1 in the denominator. I'm subtracting in the denominator. And 3 minus 2, that is 1, so only C. And then the next letter is D, because we're going alphabetically, and the D is only in the denominator. So we copy it just where it is, because there's nothing else that we need to simplify. I'm moving this a little bit to the side, okay? So we leave it there. That's it for that step, for that parenthesis. Now we're going to do the power of the power, in which this two will affect everything inside, okay? Remember, these lines are not necessary for you to do it. This one, there's no power of a power, so we don't do nothing else. Okay, so we go ahead and say, and multiply. 3 times 2, it will give me A to the 6. Very good. D to the
4.
4th power. Over 2 to what power?
To the second.
To the second power, because remember there's an invisible one in there. B to what power?
Six.
It's D and C. Sorry, to what power?
Second.
The second fraction, I didn't do anything. So I can just go ahead and copy them just as they are, because I didn't do anything at all, okay? I'm not doing anything at all because it's already simplified. Now, this is when it comes into hand, something that's called cross simplification, where you multiply horizontally, but you divide vertically or crossed, okay? Now, what does that mean? That we're going to simplify and we're going to multiply if possible, okay, before doing anything else, or continue to simplify. So this is going to give me, okay, we got 2, we begin with the numbers, 2 in this fraction, and 2 to the square in the denominator of the first fraction. And I just told you, you multiply horizontally, but you divide crossed or vertically, okay? So in this case, we are dividing because I got a 2 in the numerator of a fraction and 2 in the denominator of the other one. So I'm going to divide. And if I divide same bases, what do I do with the exponents? If I divide same bases, what do I do with the exponents? If I divide same basis, what should I do with the exponents? I subtract. Remember, when I'm dividing, I subtract the same basis exponents, okay? Only the same basis, of course. So I've got an invisible 1 and a 2 of exponents. What am I doing in there? Subtracting. Where am I subtracting? Where am I subtracting? In the denominator. So I'm going to subtract. Invisible 1 minus 2, that will give me a 1 that becomes invisible. Now remember what I told you, you multiply in a straight line fractions. So you multiply numerator with numerator and denominator with denominator. In this case, we're going to multiply the a's, sorry, because we're going alphabetically. So we got a to the 6th power and a to the square. They're both in numerators, even though they're in different fractions. You can assume that they're in the same one. So that will give me a to what power? 6 plus 2, 8. So a to the 8th power. Now let's go with the b. I got b to the 6th power and b to the 6th down to the 2nd power in this other denominator. So I also add, because they're both in the denominators, even though they're in different fractions. Now the c squared and c, I also add because you're in the same denominators, okay? Then go d's, and I got d to the 4th power and d to the 5th power. So I copy this d, they're in different fractions, numerator 1 and denominator in the other one. So I subtract. Wherever the denominator is greater, 5 is greater than 4, so 5 minus 4, invisible 1. Now I finished my simplification. I have only one variable of each and only one coefficient in this case because I didn't simplify it any longer. Yes, Maria?
Miss, I have a question.
Yes.
Miss, we can have, we got another procedure, but shorter and with the same answer.
Is that I'm placing it like every single step so you can see exactly all of the steps. But yes, it can be shorter. You can skip steps, like you can do this divisions and then passing at the same time the negatives one to the other. So yes, it is possible. I'm just doing it the longer way so you can see and understand a little better why every single step happened, why it became a 2, why it became a invisible 1, why this 2 became positive. That's why I'm doing it step by step. But of course, you can do it shorter. Now, this exercise that you have over here, guys, is your classwork. Only that exercise, it has to be uploaded today before 6 p.m. because it's only one exercise. I'm not going to accept it any other day. Are we clear with this? This is the only classwork homework that you're going to have. It will be appearing as classwork 2, extra exercise, laws of exponents or rules of exponents, okay? And it is only one exercise for you to do, okay? Okie dokie.